Alright, students, we just have one last lecture in this module, and that has to do with working with all of the data in this archive. Remember, we have like 600,000 lines of observations that are coming in, and so far most of the things that you have done with this data have involved working with just one or two stations, either just one station computing like its average or median or something like that, or two stations computing something like its correlation. But what if you wanted to work with all the stations? Like you wanted to find out something like which station had the highest average temperature in July, or which one had the highest maximum temperature, average maximum temperature in July, or something like that, where you needed to look at all the stations in Nebraska. That's what this final part of the project involves. Obviously, it's going to involve loops. I mean, there are more than 1,100 stations in Nebraska in this cooperative data observing network. You obviously are not going to be like somehow working through each one manually. You're going to be working with them in a loop. For what it's worth, we have all those stations in a file called reference table, as you might recall, but that's not where we need to do here. It turns out of those 1,100 stations, only 203 have recording maximum thermometers, so that we even have highest and lowest temperature data. Therefore, we only need the ones that are listed in that file called reporting stations. Now, that file has 203 lines, each one of which is a number of a station identifier that is over there in the reference table. But even better yet, let's actually format this bad boy to be in the format that we can read it in using our load command in Octave. So I've actually put that data into a format that Octave will like. It's in a file that's in that data, ERG 301, Nebraska directory, and I just called it reporting.stations.mat. In fact, you can kind of see a little screenshot of part of it there. And it's got 301 rows and one column, and those are just station identifiers of stations that have recording maximum thermometers in Nebraska. By the way, you'll notice that it has a fairly terrible name of this variable. The variable, when you load this array, the variable that you'll get is an array called stations with thermometers. I mean, that's a terrible name. But it does, and it makes you understand. So here's station, so the first station with the thermometer is station number 10. The second station with the thermometer is station number 16. And you could actually go into the reference table and actually look up, oh, station 10 is, I don't know, let's say Dodge, Nebraska. And station 16 is 4.5 miles northeast of Niobrara or something. Okay, so they're all 203 correspond to some location. So if we were actually going to be writing a program that was finding something like the average temperature, the station with the highest average temperature in, say, July, we would load our usual 10years.mat data set, where it's going to load that array called data that we've been working with all along, and go ahead and do all the voodoo that you now know how to do so well, where you are sorting that data, or filtering that data out to get like just the good observations. We don't want anything that's missing, and to get the right month of observations. You know, like let's say we're doing July. Okay, get rid of everything else. Okay, so you've got that all filtered there, and then go ahead and load that reporting stations.mat, and that will load up all. You know, you'll have now an array called stations with thermometers that at least tells you what stations you want to work with. Now, work with each of those stations. You know there's 203 of them, so for each station from 1 to 203, just to kind of make my life a little easier, look what I've done here. I've gone ahead and made a variable, I'll just call it this station. It's telling me what is the index, or what is the station identifying number of the station I'm working on right now. It is the ith row in this array. So we're working from I is 1 to 203, all the stations that have recording thermometers. Which one of them in reference table is this? It's stations with thermometers I. The ith row of that data tells us what the identifier is. So now we'll get a number like 504 or whatever. That is the station number from that reference table file. Okay, so now you now know the station identifier that you're going to work with. This is a station that actually has recording maximum thermometers. Okay. Now go compute that desired statistic for that station. That actually is going to involve a couple of steps, but it's going to be very closely related to what you did in the rest of this lab activity, this project rather. You have this design. Okay, now we know the station identifier. What are we going to do? Well, let's filter our data. Now, we've already filtered it for good data in the right month. Now let's filter it one more time just for the station I want right now. And so, I'm on station 10, or I'm on station 16, or I'm on station 504, or whatever. Filter it for that. And now just compute the statistic. Is that maximum temperature, or average high temperature, or average daily mean temperature, or whatever. Okay, again, that's just a couple lines, and you've been doing that and doing that and doing that in the first part of this project. Now you want to ask yourself, the question in the lab activity is, the project is this which station is the highest temperature in? I think it's July, whatever month it is. All right. Well, actually, we did something very similar to this before when we were working with that solar stuff, when we were saying, find the angle that had the highest value of the amount of solar power produced. In the same sort of way, what I want to do is I want to take that idea and I want to say, okay, I now have computed an average temperature at this station. Is that the highest, warmest station I've seen so far? Well, remember, there's sort of a little algorithm, a little technique for doing that. Before we even started any of this, we set a statistic, we'll call it highest or warmest or something, to some low number, -1,000. Okay? Then start computing your first station. Compute its average temperature. Is it greater than that highest? Well, when the first one is -1,000, it will be. All right? So then, if your station is greater, if your station statistic, like average temperature, is greater than that, then set your highest to this station's temperature, or whatever. I guess it would be temperature. And set this variable highest index or something like that to the station's identifier. Then do it for all 203 of these stations. At the end of all that, what will be in highest is the one that was the biggest. Any other one didn't go into that variable. And highest index will be the station identifier of that greatest one. This is pretty slick. You've done this before back in Project 1. Now we're just using that same technique for working with data in a different strategy. I do want to throw your attention to one little detail here. Some of the stations in this database only have their thermometer for a little while. And so since they have a thermometer, they're in there. But they, maybe only observed for a couple weeks or something. I don't know what happened. They didn't enjoy it or whatever. And so they don't, over the 10-year period, have very many, say, July observations. Well, if the weather just happened to be hot that period, yeah, you could compute the average July temperature at that station, but it isn't very representative. So since for 10 years of data for July, that would be 10 times 31 days, or 310 days, I kind of just arbitrarily said any station that had more than 200 observations in July would be enough data that we can say that this is pretty representative. And that was pretty arbitrary. Any station, almost all the stations have some missing data when the volunteer cooperative weather observer was on vacation or sick, or the thermometer wasn't working, or whatever. So when you want to compute your statistic for this station, like what its average temperature is or whatever, but then say if this is the highest and the number of stations, the number of observations which is rows in your data array once it's been filtered for station. If the station is the highest temperature and the number of observations is more than 200. Okay, it'll just eliminate some of these stations that don't have very many observations. Okay, I know it sounds a little bit rough, but actually it's not so bad. When I made this little part of the project here, I did this in 30 lines. There was more than 30 lines in my file, but if I deleted the blank lines and the comments and stuff like that, I did this in 30 lines. And actually, I happened to be doing it for average daily mean temperature. And remember, daily mean temperature is a little bit trickier than like average high temperature or something like that. If I had been doing something like average high temperature, or which station had the average low temperature or something like that, I could have done it in maybe 10 less lines than that or something. So this program is not very long once you get the basic technique down pat, and you have almost all the lines of it in this PowerPoint. Okay, that is the end of stuff I think you need to see in order to make it through Module 5 in Project 2. Please let me know if you have any questions, and good luck. I hope you enjoy this project.